Okay, geometry fans, welcome to the beginning of Chapter 5. And every time that we start a chapter, there's going to be a lot of new vocabulary. And so, for the next couple days here, the vocabulary that we use is going to be based on what we talk about today. So, what you'll notice about your notes is that the front is all vocabulary. Okay, what we'll do is we're going to define this, and we'll also draw a picture to represent what's going on. And one of the nice things about geometry is a lot of vocabulary. It makes sense, the words that we use to describe what's going on. So what we're talking about today is special segments in a triangle. We've talked about triangles quite a bit. Now there are different pieces that you can draw, extra things that you can draw in a triangle. And the first thing is called a median. You've looked at the word median, you did this in algebra, when you talked about mean, median, mode. Median basically means middle. It's a segment of a triangle that connects a vertex to the midpoint of its opposite side. Well, midpoint means middle, so those kind of go together. So basically what that means is that if we draw a triangle, and let's say we put the midpoint of the bottom, we'll put it right here. The median is the segment that connects one vertex to the midpoint of the opposite side. So that is a median. Now the way that I can label that means that these have to be congruent. If it's a median, it creates a midpoint. Let's call this AB at the bottom, and we'll call M that midpoint. So if this is a median, then that means that segment AM is congruent to segment MB. They have to be the same. Now the thing about this, and we'll draw this on the side here, you can draw more than one median. I can draw a median from this top point, but I can draw a median from this vertex on the left to the opposite side, where it bisects the opposite side. So these two segments are congruent, and I can draw another point, or another median, from the third vertex. And I'll label these with 3 marks. Okay, so what happens is you actually have 3 medians in your picture. So a median creates a midpoint, which creates congruence. Second word is altitude. Altitude, well, you've probably seen that word before when you talk about the height of something. It's a segment of a triangle that goes from a vertex of a triangle to its opposite side and is perpendicular to the side. So if we draw a triangle, and I'm trying to make these scalene. Well, that's not very nice. I'm trying to make these scalene because isosceles and equilateral are going to have some extra relationships, but I don't want you to confuse that with just a typical triangle. If I take the point at the top, the height of an object. The height is the direct or perpendicular distance to the opposite side. So I'm going to draw this straight down right here. This is an altitude. Now you'll notice it does not bisect the base, the bottom. Okay, it doesn't create a midpoint. What it does is it creates a 90-degree angle. So in altitude, you're thinking perpendicular, which means 90. So let's label points here. Let's call the triangle A, B, C, and let's call this point D where the altitude intersects the opposite side. So we've got segment AD is perpendicular to segment CB. CB is the bottom, AD, this is your altitude, and what that means is that angle ADB equals 90, and angle ADC equals 90. And what that means is that these two angles have to be congruent. Now the altitude of a triangle, if I draw, let's say, an obtuse triangle here, and I want to draw the altitude from here, how do I go straight down to this side? I would have to slant this line, but now that's not an altitude. Altitude is the shortest distance from a point to a line. So what I actually have to do here is I have to extend this, and then I can draw, I'll drop my altitude here. So sometimes the altitude can actually be outside of your triangle, which is kind of interesting. Okay, so this would be, I'll say alt. There's my altitude. And we could also draw an altitude from the other points. I could draw an altitude from here to the opposite side. That would be an altitude. And now from this point, I would have to extend this and then draw it like this. Okay? So we've got a median creates a midpoint. It bisects the opposite side. An altitude goes from a vertex to the opposite side. It creates 90. It's perpendicular. And both of these are 90. Okay, both of these angles. Now the third one is an angle bisector. We've seen this word, angle bisector. It's a segment of a triangle that goes from a vertex to the opposite side and bisects the angle. All right, so if we draw our triangle. Now, an angle bisector is going to bisect not the side, it bisects the angle. So it's from the vertex where it starts, these two angles are congruent. That's an angle bisector. Now we could go ahead and label the points again. A, B, C. We'll call this D. This tells us that angle CAD is congruent to angle BAD. So an angle bisector creates congruence. Notice that all of these, median creates congruent sides. Altitude creates 90 degrees, 90-degree angles which are equal. Angle bisector creates congruent angles. So all of these are giving us relationships that we might be able to use to solve a problem. An angle bisector, just like a median, just like an altitude, you could have 3 of these from each vertex. So one from here, one from this point on the left, if I bisect this angle, and then one from this point on the right. All right, and the last one is kind of a combination. It's called a perpendicular bisector. Well, the first 3, the median, the altitude, the angle bisector, they all start from one of the vertices, one of the points on the triangle, and they go to the opposite side. A perpendicular bisector does 2 things. It's going to be a segment that bisects and is perpendicular to the side of a triangle. If I take the bottom side here of my picture, all right, let me put a midpoint on there. So there's my midpoint. Now, to be perpendicular, if this is horizontal, this would have to be straight up and down. So when I draw this, this is going to be a little bit different because if I draw that straight up, notice that that does not go through a vertex. So a median has to start from one of your 3 vertices. An altitude and an angle bisector have to start from one of your vertices. A perpendicular bisector does not. It needs to create a midpoint, there's M, and it needs to bisect the side. Okay, so this one does not have to go through a vertex. Now there is one special case here, actually 2 special cases. An isosceles or an equilateral triangle. Okay, let's just say, it doesn't matter if it's equilateral, we'll say it's isosceles. If you drop down this segment, let's say we drop this altitude, we're going to use this a lot with right triangles. You know a couple things are going to be true here. This is an altitude, so it means it creates 90, but because these 2 sides are the same, when we drop this down, it is also going to bisect the opposite side, which makes it a median. It's also going to bisect these 2 angles at the top, which makes it an angle bisector. And because it creates a midpoint, and it's also 90 degrees, it's a perpendicular bisector. So if your triangle is isosceles or equilateral, this segment is actually all of them. This is the only case where you can say an altitude is the same as a median, is the same as an angle bisector, is the same as a perpendicular bisector. Okay, so that's only true in that situation. All right, that's the end of part 1. Go ahead and flip it on the back and we'll look at part 2.